Good day, viewers. You are welcome. Here we have a nice geometry challenge. We have a triangle which we have an inscribed semicircle in it. Actually, this semicircle is not drawn to scale. So I mean a semicircle by this in a blue shaded form. I want to find the area of this semicircle which is in a triangle. We have the side of the triangle as 5, 3, and 4. And how can we find the area of this triangle? So, to find the area of this semicircle, we are going to have the area of circle itself, which is pi r squared, while the area of semicircle is given as 1 over 2 pi r squared. Then, if you consider the center of this circle, at this point, if I draw it to this, we have this as the radius, and this line is at the tangent to this line, and every tangent line is at perpendicular. And also from here to here, we are going to have it as radius as well, which means if this is radius, this is also radius, and this side is also r. Well, from here to here, we have it as 3. Since from here to this point is r, definitely from here to here will be 3 minus r. And similarly, we have from here to here, that is 4. So which from here to here as r, then here becomes 4 minus r. And suppose I call this point angle of theta. Let me call this one theta 1. So if this is theta 1, here is also theta 1. This is corresponding angle. Because if we have a line like this, and we have two parallel lines, so we have a line that crosses it, that is a transverse line. So anything that happens here happens here. So suppose I call this one an angle. So if this is an angle theta, definitely this is also an angle theta. So they are corresponding to each other. So again, we have this, if I call this one theta 2, so this is also theta 2. That's also correspond. Then, so there are two things here. We have 3 minus r. So this is r. We have here as r. This is 4 minus r. So we can take out these two triangles. So note that these two triangles are equal, but this is not drawn to scale. So by taking out these two triangles, we are going to have a line like this. So here we have a triangle, and this is also a triangle. So here gives us r. This is 3 minus r. Here is r, and this is 4 minus r. Then we have this as theta 1. This is theta 2. This is right angle. Also, this is theta 1. This is theta 2. So from what we have in this part, we can just see that these two angles are equal. Then 3 minus r divided by r, it will equals r divided by 4 minus r. So this is what we are going to have. Then by solving this, we cross multiply as r multiplies r. When r multiplies r, we have it as r squared equals, then 3 minus r will multiply 4 minus r. So here is r squared equals 3 times 4, that is 12 minus 3 times r minus 3r minus r times 4 minus 4r. Adding the two together, we have minus 7r, then plus r times r, that is r squared. So r squared cancelled r squared at these two sides. So here we have 0 equals 12 minus 7r, and here we have 7r equals 12. If 7r equals 12, then we have r equals 12 divided by 7. So this is what we have for r. And on getting r, then we are going to substitute back to get the area of semicircle. So this implies that area of semicircle equals 1 over 2 pi r squared, and r is 12 divided by 7. So replacing it, we have 1 over 2 multiplied by pi multiplied by 12 over 7 squared. And 12 over 7 squared, it gives us 144 divided by 49. So 2 here, 1, and 2 here, that is 70. We have this as 72. So here is 14. This is 72. Then we have area equals 72 pi divided by 49. And this is the value for area of semicircle. Thanks for watching, and see you in the next video. Never stop learning. Bye bye.